is a pre-recorded FastCast, so if you'd like to jump to any other portions of the FastCast, feel free to use this audio-visual table of contents. All right, everyone, it's 1 o'clock, so we're going to get started. I wanted to welcome everyone to MoreStream.com's 6th EngineRoom FastCast. Today we're covering improve and control phase tools. My name is Gabe Turk. I'm the Retail Accounts Marketing Manager at MoreStream.com. And today we're going to go over the functionality and use of some of the improve and control phase tools. Just a side note, if you have any questions during the FastCast, there is a questions button on your GoToWebinar side panel. So you can type questions to the group or just to me within that area. I'll address all the questions at the very end of the first 15 minutes. If you have any questions during or after, feel free to stick around and I'll address those questions at that time. So with that, let's get started. The first thing we're going to do is go into EngineRoom. The way that you can get into EngineRoom, if you're in one of our courses, you can access it through your side panel. You can go to MoreStream.com and get into your account, or you can go to EngineRoom.MoreStream.com if you also have an account and log in. The first thing we're looking at here is our home screen. In our home screen, you're going to see a list of all the projects you've already started. If you need to start a new project, you can hit New Project, but I've already created one for us, so I'm going to open up a project that has some work done in it already. So today we're going to go over Fmea, Little's Law Calculator, the control planning tool, X and moving range control charts, cumulative sum control charts, and the X bar and R control charts. So the first thing that we're going to jump into is the Fmea. Fmea is the failure mode effects analysis, and it's used to proactively evaluate or investigate a process to find when or if a process can fail and what the impact of those failures may be or what they are. So in order to access the tool, we can either go into the drop-down menu of Improve and find Fmea, or we could always use the search bar to type in Fmea. So I'll go to Improve and click Fmea. When you're in this template-based tool, there's a couple of things that you can do I want to get you familiar with before I give us an example. All of the tools that look like this, you're going to be able to click into these areas and change the text. So if you use a different name than what we've standardized here at your company, feel free to type that in. Or if you just want to make a note to yourself, feel free to do that too. If you need to add more rows for new process steps or for other failure modes, you can always hit Add Row. And if you want to familiarize yourself with the tool a little bit, you can always look at the instructions button to get a quick overview or use the help menu up at the top right. So now that we've kind of got familiar with it, what I'm going to do is open up an Fmea that I've already created with a small story around it. So I thought an easy thing to look at would be laundry at my house. My girlfriend and I do laundry all the time. And what are some things that happen with that? What are the different process steps? So you'll see here in the process steps, I've typed in some information. So for laundry, I have to take the hamper to the laundry room, separate the clothing by the color, place the clothes in the wash, place the detergent on the shelf, and so on, okay? And so what I'm going to do is look at each of these process steps and type in what some of the failure modes are. So where could this process go wrong? So for this one, I said, well, maybe I didn't collect all the clothes. All right. The next step over, you're going to look at the severity of this failure mode. So when this failure happens, how bad is it? 10 is the most severe, 1 is the least severe. So if you click this area, you're going to be able to select 1 to 10 from this dropdown. So I'll select 2 because that's what I already had in there for us. For occurrence, so basically how often does this thing happen? 1 to 10, 10 being the most often, selected 7. And detection probability. So am I going to catch this mistake before it happens or before it gets really out of hand? 10 is going to be a low probability of me catching it. 5 is a decent probability, 1 of course being the lowest. So I selected 5. So in regards to this situation, the risk of this failure happening to our entire process and how bad it is 70, and that's found from multiplication of all these different points that we've put in, all these numbers. The action to improve. So this is something that maybe we think we can do to rectify this problem or minimize this problem. Maybe it's some kind of control we put in place at our certain processes. So for this one, it's pretty easy. Maybe I just ask my girlfriend if she has anything else that she needs washed. Problem solved. So I went through and did that for all the different process steps. I want to point out number 7 here. So you'll see that I have drying clothes. There's a couple of failure modes that I've inputted. So to organize this chart properly, though I have one process step, I may have different failures or multiple failures. So all that I've done was add in failure mode and I just skip a space for the process step and put 7A, 7B, 7C, so on. So, maybe another failure mode for separating the clothing is I don't really understand if gray is a light color or a dark color or where it goes, or, what is a red, or how light does red have to be before it goes into light? All the common problems I think that most people just kind of question in their mind. So I walked through the severity, the occurrence, the detection of it, see that it's a pretty big problem, and maybe there's a particular action we can have. So maybe we need to revisit the operational definitions of what colors are with the team, right? So that's the long and short of how this tool is going to work. You'll notice too at the very top, I just clicked this area and that's how I renamed this. So you can rename all of your tools and data like that. I'll X out of this. And the next thing we're going to do is go into the Little's Law calculator. I'm going to find that by going to Improve and hitting Little's Law calculator. I've already created one for us, but just so you know, what it basically is a tool that's going to allow you to type in your work in progress process or your completion rate to get your cycle time, or you can type in your cycle time, your completion rate. It's all based on what kind of data you have and don't have. And to specify values, you can just put your unit of time here and type. So if I want to change hours to seconds, I could do that. The work in process. So work in process is basically how many things are in your queue, or if we're doing laundry, it's how many loads I need to do. So let's say I need to do 50 loads of laundry. And the completion rate. So how many am I getting done in this given unit of time? So let's change this back to hours. Let's say I get 2 done per hour. You'll see here my cycle time is updated to 25. So that's going to let me know that it's going to take me 25 hours to get through all of these loads of laundry. And that same kind of functionality and thought process works for all of these tools. So they're independently calculated. Just type in the data that you have, and you'll be able to get your calculations. So I'll X out of that. And the next thing we're going to go into is our control plan. So I've already created a control plan for us based around this laundry example that we were talking about. I'll move this to max mode so it's a little larger. The whole focus of the control plan is to document and track the significant factors of your process. So being in the control phase, we would have already done a lot of different tools or used a lot of different tools throughout the phase of our project. So we may have done fishbone diagrams or a CTQC diagram to figure out what critical characteristics are. And that's going to help us fill in this information here. So what I did was I took one of my items from my Fmea. So I have the clothing gathering, I have the clothing separation here. So as I filled it out, I have inputs. So how did I determine, or what are the inputs for this particular process or this part of the product or whatever we're analyzing? So I just said C fishbone. Let's say I had another fishbone I created. I did the same thing for the output. For product characteristics, I could draw some CTQC that I found or created in a past chart. So I can just literally copy and paste that information into here. As I move through, you can type anything that you want into these boxes, and if you need to make more space for any of these, you can just toggle the sidebars to adjust your table sizing. And just real quickly to see how this all fits into the use of improve and control phase tools. So we were mentioning a lot of these first couple of areas have to do with define, measure, and analyze maybe. But as we go through, we're going to look at the methods. So how are we going to check how our process is working or how we're doing in terms of our changes, what we're doing to measure it, maybe what kind of units are we using, what are we doing to measure it, sample size, how big is our sample size that we need to represent the population, the method frequency, so how quickly or how often are we taking measurements, and then the control method is going to be the actual tool we're going to use to put all of this information into action and verify it against our standards that we've set or the changes that we put into place. So I'm going to X out of that. Once you complete your control plan, especially for this laundry example, let's say I wanted to print this out. For any of your tools, you can hit the print button and change the orientation of your chart or your graphs or whatever it is and hit print. When you hit print, you can either print it to a printer, as the name would suggest, or as you know, you can print things to a PDF using your native print screen. So the long and short of the template-based tools we're going to cover today, and now we're going to go into the control charting tools. So first one we're going to look at is the X and moving range chart. So before we get into the X and moving range chart, we're going to want to upload some data. So what I'm going to do is show us a Microsoft Excel spreadsheet that I have down here. to get us familiar with some data, and I'll be distributing this data later too, so you can try this at home or at work. So what I have here for my control chart data is I have loads completed, and I just have the list of loads that I've completed of laundry and what day that I've completed it. So if I want to put this data into EngineRoom, I can highlight all the information I'm interested in, hit copy or Control C or Command C if you have a Mac, go back into EngineRoom, and hit the plus button. The plus button will give me a new spreadsheet up here. And if I click and drag that open, I'll be able to go to this very first cell and paste the information that I copied from my spreadsheet. Maybe I'll rename this whatever I'd like to by clicking there and typing. And I'll hit Save Changes to save my data. So once that's saved, I'm going to close it and go into Control, go under Control Charts, and find my X and moving range chart. There's going to be a couple of drop zones that you're going to be able to put data into. So you have your data, you have your time-oriented information, a stage variable, which is often used to show shifts in your processes. In order to put data here, I'll go to that spreadsheet that I uploaded and I'll click it once. I won't drag it like before. And you'll see that there's going to be hexagons that represent each of the columns from my spreadsheet. So if I want to take the amount of laundry loads that I completed, I can put that into the data variable. And then if I want to put my date hexagon in, I can put that into the time order variable. So one of the main purposes here with this X and moving range chart is just to see where the process is getting out of control and see if we have any special cause variation. So here I see there's these 2 points that went out of control. Perhaps if I want to be a little bit more precise, I can hit the settings button in the top right and toggle all the different kinds of Westinghouse rules that are involved for control charting limits. If I turn any of these on and my data reflects that, it'll point it out for me. So that's the X and moving range chart. Next, I'll go into the X bar and R chart. It's a very similar tool. However, it gives you a little bit more flexibility and is also a little bit more sensitive of a tool. So I've already uploaded some data for this. It's just the amount of loads that we've completed with all these different subgroups. So a subgroup could be taking measurements. Maybe I took a measurement in January and February and so on. So one represents the months that I took measurements over the years. So these all represent January numbers. What I can do is, just like I did with that X and moving range chart, is take my amount of laundry loads completed, maybe place my subgroups on. And now we're going to be able to see this chart that has to do with the relation of these subgroups. That's how these points are plotted. So if I hit max, looks like it's pretty in control. So from month to month, it looks like we're okay. If I want to toggle between the different charts, and this stands for any of the statistical tools, at the bottom you'll be able to click range chart or X bar chart to toggle back and forth from different tools. If I want to make any kind of notes, I can always hit this annotate button, click onto the graph, start typing, maybe adjust the size and the color if I wanted to of that note. So just a couple of other things you can do with charts. The very last one we're going to go into is the cumulative sum chart. This is the newest control chart we've added. It's also the newest tool that we've added. I would caution you, this is not a frequently used tool. It's a very sensitive tool, and it's when you're looking for very small, intricate shifts in your process. There's also a little bit more of information that you're going to need to know about it as well. First thing I'll do is just grab some data so we can look at it. So I'll take errors. So let's just say I have a specific amount of errors. I'm going to put it onto my data here. And I'm going to need to specify some historical information or targeted information. So standard deviation is, what was the standard deviation of my historical process? If I cursor over my hexagon, I can see that the standard deviation is 0.05709. Let's say that was my historical deviation just for this exercise. So I'll type in 0.0579. The target is going to be the target value that I'm looking to hit. So if I open up my chart, I see that most of my values are around 2. Maybe that's 2 is the number that I'm looking for. That's where I want most things to be at. So if 2 is my target, I'm going to type 2 in. Decision interval is basically a piece of your standard deviation. It's the look at the height of your lines based on some statistical equations with your standard deviation. So it's typically between 3 and 6. So I'll just type in 4. This is fine. And for our shift, This is standard deviation, so it's going to be 0.5 to 1. I'll leave it at 0.5, and I'll leave my subgroup size as it is. And I hit update. Okay, then we're going to have our chart. So this is called the cumulative sum chart because each of the points are going to be accumulated, and that's where we get each of these points. These dips, and the reason why you see 2 is that they kind of trend together. So you'll see that as there's a dip here, it's also going to be consistent at the very bottom, and it's also going to tell us that, okay, since there's a huge dip here, we're going to notice that maybe there's a lot of negative values in this area. We know there's a ton of negative values and consistently at this area here. To give a slightly better understanding of how I came up with that, I want to show you this spreadsheet really quickly. So you'll see in the spreadsheet, I have all of the data that I inputted. This is what the hexagon that I dragged onto EngineRoom. But what I have in this next column is the calculation. The calculation is going to be the sum of any value that preceded it. There's also a little more into the equation, but this is kind of the long and short of how it works. So you'll see that my calculation here is 2 minus my target of 2 is 0. And then we're going to see that sum happen again with the subtraction. And we have this point, I'm sorry, we'll have 2 minus 2.04, which gives us 0.4. And then it'll go on and on until you get to kind of the bottom. So if we look at the equation here, it's just going to be the sum of these minus 2. Oops, sorry. So let me get out of that. I'm confusing people because I clicked the wrong thing. Anyhow, that's the long and short of the Q-sum charts. I just want to point out this is a seldomly used tool. So if you are using it, make sure that you know you're using it, know why you're using it, and how you're going to use it too. X and moving range and X bar are the most typically used. So, all right. With that sums up everything I want to show everyone today. So I want to thank you for your time and look forward to your attendance to future FastCasts. Thanks so much. Take care.